Hi everyone, my name is Rahima and I'm a developer advocate engineer here at Zoom. In today's video, you'll watch me build a full stack application based on our video SDK. Now, if you're not familiar with Zoom's video SDK, I'll give you a little snippet. Think of this as the fully customizable software developer kit. It allows you to combine your unique voice and your brand with the top tier quality you've come to know and expect from Zoom. You'll gain access to video, audio, and an array of other features all within the session that you create. If you'd like to learn more about the Video SDK, I encourage you to click on the link in the description box. Now moving on to the task at hand. As mentioned, I'll be building a full stack application using React on the front end and Express on top of Node on the back end. I'll be building out my server side so that I can safely and securely store my API key and secret and consistently generate my Video SDK JWT that I'll need to join and initialize sessions. All right, now let's go ahead and start building by moving into our code base. All right, so in our code base now, we're going to go ahead and start by building on the back end. And the first thing we're going to do is build out our server in a file called server.js. So in server.js, let's go ahead and review some boilerplate code that's already present. On line 1, you'll notice that I'm requiring in the package Express that's already been installed into my project because, again, I am building with Express on top of Node. On line 5, you're going to see that I am attaching an initialization of the Express application to my created variable app. And then on line 9, I'm pulling in a necessary piece of middleware to use in my server so that it can correctly parse through incoming JSON objects. So that piece of middleware is called express.json. On line 10, I am declaring my port. I'll be using port 4000 for my project. And then on lines 15 through 24, you're going to see that I have added in some global error handling. So if any of my handler functions throw out an error, I can log that to the console and then debug accordingly. On lines 26 through 28, I'm binding my connections to my port. And on lines 30, I am exporting out my created app. All right, so now we're going to go ahead and create the only route that we need for this project. That route is going to be a post request. And the reason for that is that we're sending some information from the front end to the back end. So our back end is being used to generate our video SDK jot. And you always need a jot when working with the video SDK to initialize or join sessions. The payload for the video SDK jot requires user credentials, and that's the information that we'll be sending from our front end to our back end. So again, this is what requires us to make a post request. So we're going to call app.post, and then the first parameter I'll be passing in for this is going to be the endpoint I'll be using to access this route. That endpoint I've called that endpoint generate simply because I am using it to generate my signature. Next, I'm going to pass in the default handler function that's always included with any routing method, and that's going to be my callback function that sends something to the front end. So it has its two default parameters, which is the request object and the response object. And I'm going to go ahead and leave that return statement blank for now. We'll come back to that in just a moment. We're going to add in another handler function after our endpoint in our post request. And that's going to be a middleware function that's been built out in a separate file. So let's go ahead and jump into that file and see what this middleware function is doing. All right, so inside of middleware.js, I have the logic for generating my video SDK signature. Now, this logic is the same that can be found in our documentation. I took it straight from there, and I only made a few changes because now we're using it on the back end versus the front end. So I'm going to go over what those changes are. First, you'll see me pulling in the package JSRSA sign at the top, and this is what's being used as a cryptography library for creating that signature. Next, you'll see we're pulling in the .env package and calling the config method on it. Now, .env allows me to read in environment variables safely into my file. Next, I'm just creating my object that I'm exporting down on line 43. I named it middleware, something very generic for the sake of this demo. Typically, you want to name it something a little bit more specific. And then we're going to see on line 6, and I'm passing through the default arguments or default parameters for this method because it is a middleware function. So that's my request object, my response object, and the next next. Now, what next does is tells my post request or my route to move from this handler function to the next handler function listed in its parameters. Now we have a try catch block, which is the same as the logic that's being used in our documentation. I added in a variable called signature and set it equal to the value of an empty string. And now what I'm going to go ahead and do on line 16 to access my user credentials is deconstruct or destructure my request body object that's being pulled in. So I'm going to go ahead and say const, and I'm going to set this equal to the request body. And now I'm going to go ahead and fill in what those values are. So we have topic, password, user identity, session key, and role type. Now, not all of these credentials are necessary for generating your video SDK job. You can refer to our documentation, which is linked below, to see what is necessary and what's not. But for now, I have all of them listed. Next, on line 17 through 18, you're going to see that my SDK key and SDK seeker are being read in using process.env. Those are being stored as environment variables because they are sensitive pieces of information. So now we're creating our payload, we're generating our signature, and what you'll see that I did on lines 34 before my return statement is I saved that created signature to my res.locals object. So again, that is my response object, and because I've saved it here, I'm able to access it and send it to the front end on my server file. So let's go ahead and save this and jump back into the server. All right, so I'm going to go ahead and pull in that middleware object that I just created. We're going to say const middleware is equal to require middleware. All right, so now I have that pulled in, so that's being recognized on line 13 as the object we just created. And then what I'm going to go ahead and do is create my return statement. So the first thing I'm going to do is send a status of 200 because everything is working. And then I'm going to go ahead and send my response body, my response object, accessing the locals object within it, and then accessing that saved value of my signature that I just saved in my middleware.js file. All right, so I'm going to go ahead and save this, and we've created our server. So again, our server is receiving information from the front end in the form of a post request. It's taking that information and using it in our middleware functionality to generate the video SDK jot or signature, and then we're saving that signature in our response object to send back to the front end. All right, so now we're going to go ahead and move into our front end files and work from there. So in our front end, the first file that we're going to start with is going to be our entry point index.js. In this file, the first thing we see is that we're doing all of our necessary imports at the top. I want us to look at line 5 because here we're going to see that I'm pulling in something called Zoom context. Now, this is an object that I created in a separate file, and it's a context object because I'm going to be using context API from React throughout this project so that I can easily share different pieces of data and state throughout nested components. Looking at line 10, we're going to notice that the first thing that's being done is we are creating a new object based on a copy of an imported object, devconfig. So if we look inside of the file that this object comes from, devconfig.js, we're going to notice that it contains the necessary user credentials for joining and initializing a session. So back inside of index.js, the copy of that object has been saved to a new one called meeting arguments. Looking at line 12, what I did here was create an asynchronous function that takes in one parameter called getToken. So the function getToken is going to be responsible for making the fetch request to the backend and receiving that generated video SDK jot. So in this function, I'm going to declare a variable called response and set it equal to the output of making a fetch request to that endpoint that we specified, generate, and I'm going to pass in options as an argument. Because this is a promise, we're going to go ahead and chain on the then method. I'm going to take the response, read it to completion using the JSON method. And then the last thing I'm going to do in this function is return out my response. Then what I'm going to do on line 21 is look to see if my meeting arguments object contains a signature. If it does not contain a signature, but it does contain a topic, I'm going to go ahead and invoke getToken so I can get that signature. So because it's a post request, we do need to send an object of options to the server. So inside my object called request options, I'm going to add in the method, which is going to be the post method because it is a post request in our server. Then I'm going to add in the headers that I'll be using. So I'll only be utilizing one header, and that is content type. Going to set that equal to application/JSON. And then the last piece of information that I'll be sending is going to be the body, which is going to be the stringified version of my meeting arguments object. So I'm sending those user credentials to the server so that it can go ahead and use them to generate a signature. The last thing I'm going to do inside of this conditional is invoke get token, passing in request options object as an argument. Then again, because it's a promise, I'm going to chain on the then method. I'm going to take the response from this fulfilled promise, and I'm going to save it to my meeting arguments object under the key signature. So just a recap of what we did here, on lines 12 through 19, we went ahead and created this function called getToken, an asynchronous function that makes a fetch to the backend and returns back out that generated video SDK JOT. Then inside of this conditional, we checked to see if the signature was present. If it was not, but we had the topic present inside of our meeting arguments, we sent to the backend the request options that contains the method, headers, and body, and the body was the meeting arguments object. So once we send that to the backend by invoking getToken, we take the response from that promise, from that fetch request, and we save it to our meeting arguments under the key signature. All right, so now that we've wrapped up that portion, we could look at line 33 and see where we are creating our client by calling the create client method on our imported Zoom video component, which is coming from the Zoom Video SDK package. Then we're rendering our application to the DOM. So if we look at lines 39 through 43, we're going to see on line 41, we are passing through the app component that we imported on line 4. And we're also wrapping this in a context, the context provider from the context API that I'm using. So I'm calling that Zoom context object that I imported, calling the provider method on it, and then I'm passing in my created client as the value so that I can now access this in nested components. Then on line 41, back where we see that we're passing through app, I am doing some prop drilling by passing down my meeting arguments object that I created. All right, so now we've created index.js. Every time our application opens, it's going to go ahead and run through this functionality so that we can have a completed meeting arguments object to send into our app component. Now that we've done this, we can go ahead and look at app.js and start building that out. All right, so looking inside of app.js, the first thing we're going to see is, again, we have our necessary imports happening at the top. If we look on line 4, we'll see that I'm pulling in a piece from the UI library that I'm using for this project, and that's Ant Design. And on line 6 and 7, you're going to see that I'm pulling in 2 different context objects. And again, that's because I'm using context API from React for this project. So moving into our functional component, we're going to notice on line 15 through 17, the first thing that I'm doing is destructuring that props argument that I passed in. So this gives me easy access to the meeting arguments object that I prop drilled down from index.js. Then on line 19 through 22, we're going to see that I am making use of the use state hook from React. Now, the use state hook allows me to create simple pieces of state and change them with a set function. So for instance, on line 19, the state I created is loading. It can be changed with the function set is loading, and it's a Boolean whose default value is true. Now moving on to line 25, we're going to see that I'm making use of the use context hook from React. So use context allows me to grab pass down values from specified context objects and use that in the current file. So in index.js, I passed in the value of my created client to my context provider wrapper. So now I can set that value of my created client equal to this new variable client. So now we're going to go ahead and move into the functionality of initializing and joining a session with the Video SDK. I wrote this functionality inside of a use effect hook so that it's performed as a side effect and only occurs when there are changes to any of the features that I'll mention later on. So inside of here, first thing that I'm doing is creating an asynchronous function, and that's called init. Now what init is going to do is call the method init on the client that we created, and this method is going to initialize the session, and it takes in 2 necessary parameters. The first one's going to be the language that we're using. In this case, it's English. And the second one is going to be the deployment path for the dependent assets. So in the case of the video SDK, the dependent assets are going to be the web workers and WebAssembly that's used to process the media stream. More information about this can be found inside of our reference guide in our documentation. All right, so this is a promise. So we'll be using a try catch block. If my meeting is successfully initialized, I'm going to move into my try block. And the first thing I want to do is join my meeting. So I'm going to call the join function on my client. And this takes in 4 necessary parameters: topic, name, password, and that signature that we generated. So now that I have joined my meeting successfully, I'm going to go ahead and set my media stream. This allows me to manipulate any incoming media like video or audio. So I'm going to create a variable called stream and set it equal to the output of calling get media stream on my client. So now what I'm going to do, now that I've joined my session and I've created my media stream, I'm going to go ahead and set a few pieces of state within my try block. The first one is going to be the loading text. So this is just going to tell my user what's going on, and I'm going to tell them that we're joining the session. The next one is going to be my media stream state. So I'm going to call the function set media stream and set it equal to that value right above stream. And the last thing I'm going to do is set my loading state. So I'm going to set this to false because we are no longer loading. We've loaded and joined the session. All right, so if my promise is not fulfilled, I'm going to move into my catch block. And in here, I'm going to throw the error out to the console. And I'm also going to set my loading state to false because we're not loading. We were unsuccessful in joining the meeting. Now we're going to go ahead and move on to calling our function that we just created. So still inside of my use effect hook, I'm going to go ahead and call init, that function that we just made with the try and catch block. Then my cleanup mechanism for my use effect hook is going to be to destroy my client. So before this ever re-renders, I'm going to destroy the client and end the session. Now, this use effect functionality is only going to happen if there is a change to my SDK key, signature, client, topic, name, or password. All right, so we have written that functionality. We're going to go ahead and briefly look now at the return statement. So this is mainly UI, but the one thing I do want us to pay attention to here is that I'm using a context provider again, and I'm passing in the value of my media stream. Now you'll remember that we created the media stream using useState, and we set it down here using the set media stream function. So I passed in that value, making it accessible to my nested components. Okay, so now that we have joined our session, we're going to go ahead and move into the functionality for getting our media up and running. So in video.js, this is going to be where we are handling our media. So starting our video, starting our audio, and screen sharing. At the top, again, we have necessary imports happening. Moving inside of our functional component, we have use of the use state hook again to set simple state, and we're using use context to grab different values. On line 20, there's a function called isSupportWebCodecs. This is going to be relevant for when we get to screen sharing, so we're going to wait and come back to this. Now on line 24 is where we're going to write this functionality for getting our video started. This is an asynchronous function, and it's wrapped inside of a use callback hook. Now, whether or not you want to use a use callback hook is up to you, but I did want to point that out because all the functions on this page are wrapped inside of a use callback hook. So I'm going to first check and see if my video is even started, and I'm doing that by using the video started state that I created back on line 10. So if my video isn't started, let's go ahead and get it started. I need to check and see if I'm 1, inside of a Chrome browser, and 2, if I have SharedArrayBuffer enabled. So SharedArrayBuffer is an API used by the Video SDK for a more enhanced experience. So for instance, SharedArrayBuffer is what allows us to use gallery view. More information about this can be found inside of our documentation, which again is linked below. So I'm checking to see if I'm in a Chrome browser, and I'm also going to go ahead and check my SharedArrayBuffer and see if that's enabled. All right, so if I am inside of a Chrome window, but I do not have SharedArrayBuffer enabled, I am going to go ahead and start my video in a specific way. So first, let's set our SharedArrayBuffer state. I'm going to set that to false. And then I'm calling the start video method on my media stream. And then I'm passing in a video element as my HTML tag. So this is a distinction that I want to make, and we're going to see how this is different from when we do have SharedArrayBuffer enabled in just a second. So I'm finding my HTML tag by using document.querySelector, and we're going to see here the ID is self-view video. So again, we're using a video tag or a video element as our HTML tag because we do not have SharedArrayBuffer enabled. And let me go ahead and add my await because this is an asynchronous function. All right, so alternatively, if we do have SharedArrayBuffer enabled, we want to go ahead and set our state accordingly. We're going to set that to true. And now we're going to go ahead and again, we're going to call mediastream.startVideo. This time, I'm not going to pass in any arguments to my start video method or function. Instead, I'm going to call another method following this. It's going to be mediastream.renderVideo. And this takes in a number of necessary parameters. The first one, again, is going to be our HTML element that we'll be using. So we're attaching this to the HTML tag HTML ID self-view canvas. So that's the distinction I want us to pay attention to. When we're working with SharedArrayBuffer, we'll be using a canvas element for our HTML tag. When we're working without SharedArrayBuffer enabled, we'll be using a video element for our HTML tag. So the next parameter that we're going to be passing through is the current user ID. And I'm going to grab that by calling get current user info on my client, and then I'm going to access the user ID value. Now, the next thing I'm going to go ahead and do is pass in some dimensions. So this is going to be my screen dimension. Then I'm passing in some X and Y vertices. And my last argument is going to be my screen or my video quality, and a value of 3 is equal to a quality of 720p. All right, so let me go ahead and just review this, make sure I did everything correctly. I'm checking to see if my video is started. It's not, so I'm going to go ahead and check to see if I'm in a Chrome browser and if I have SharedArrayBuffer enabled. So I don't have it enabled. I'm going to go ahead and set my SharedArrayBuffer state to false, and then I'm calling my start video function on MediaStream, and I'm passing in a video element as my HTML tag. Cool, that looks good. Moving on to if I do have SharedArrayBuffer enabled, I am going to go ahead and set that state to true. I'm going to first call start video on my media stream, and then I'm calling the additional function render video, passing in a canvas element, getting my current user ID, and then passing in my dimensions and my video quality. All right, that looks good. So the last thing I want to do inside of this conditional is just set my video started state accordingly. So I'm going to go ahead and call that function, should be set video started. And we're going to go ahead and set this to true because we have now started our video. So elsewise, if we do not have our video, or if we do have our video started, we're going to go ahead and stop the video. So I'm going to go ahead and call mediastream.stopVideo. Now I'm going to check and see if I have SharedArrayBuffer enabled. So using my state to do so, if it is enabled, I'm going to go ahead and call an additional function, mediastream.stopRenderVideo. And now I'm going to go ahead and pass in only the first 2 arguments. So that's going to be the HTML tag that I'm using, and it's also going to be the current user ID. So using query selector to find that, passing in self-view canvas. Again, it's a canvas tag if we do have SharedArrayBuffer enabled. And then I'm going to go ahead and also pass in the current user ID by calling get current user info, and then accessing the user ID value. All right, last thing I'm going to go ahead and do inside of this block is set video started to false, because now we've turned off our video. And this is only going to be triggered when we have a change to our media stream, video started, client, or our SharedArrayBuffer state. Let me go ahead and save this, and now we're going to go ahead and move on to audio. Now, getting our audio started is going to be a lot simpler than getting our video started. Here, we're going to look at how to start our audio and how to mute or unmute our audio. So we're going to check first our state and see if our audio is started. And if our audio is started, we're going to move on to muting or unmuting our audio. So then we're checking our muted state as well. And again, we created all these pieces of state using our use state hook at the top. So if our audio is muted, what we're going to go ahead and do is call the function MediaStream.onMute audio. And then we're going to go ahead and set that state accordingly. So set is muted, and we're going to go ahead and set that to false. Now, if we are not muted, what we're going to go ahead and do is call MediaStream.mute audio. So we're muting ourselves, and then we're going to set that state accordingly. Set is muted to true. Now, what we're going to do otherwise, if our audio is already started, we're going to go ahead and, or I'm sorry, if our audio is not started, we're going to go ahead and start our audio. All right. So this is how we start our audio, how we mute ourselves, and how we unmute ourselves. And this functionality is only going to be triggered if we have a change to our media stream, audio started, or is muted. Again, this is wrapped inside of a use callback hook, and it is an asynchronous function. Now, you may notice that I did not go over how to stop audio, and the reason for that is only because of my UI setup. So you'll see at the end of the video that the UI is set up in the way that the mute button is the same as the start audio button. If I wanted to incorporate the stop audio function, I would have added in a drop-down menu or a separate button for muting and unmuting and starting and stopping audio. So I'll mention that again when we get to the demo, but I did just want to point that out. Otherwise, stopping your audio is as simple as calling MediaStream.stop audio. Now we're going to go ahead and move into sharing our screen. So I'm going to jump back to that function and explain a little bit more. So the function that we saw before was is support WebCodecs. Now WebCodecs, similar to SharedArrayBuffer, is an API that can be used to access different components of raw video or audio. Now, we want to use this to see how we're going to go ahead and render out our shared screen. So that's why this function is important, and we'll be using it below. So inside of our shared screen function, we're doing the same thing and checking our state to see if our screen is already being shared. So if is share screen is true, we're going to go ahead and just stop sharing the screen first. So we're going to call await MediaStream.stop share screen. And then we're going to go ahead and set that state accordingly. It's going to be set to false. And if our screen is not being shared, then we're going to go ahead and start sharing. We're going to go ahead and start sharing the screen. And we're going to do so first by checking to see if WebCodecs is supported. So I'm going to call that function and look for its output. If its output is true, I'm going to go ahead and call the start share screen function. And I'm going to pass in a video element as my HTML tag. So this is similar to what we did before with SharedArrayBuffer. We're determining whether or not we're going to be using a video tag versus a canvas tag. So in this case, we do have WebCodecs supported. So we're passing in a video tag. What is the issue here? Let me add in that missing parentheses. So now what we're going to go ahead and do is start our video if we do not have WebCodecs supported. So we're going to call the same function. And this time we're passing in a canvas element. So again, I want to make that point clear. If we have WebCodecs supported and that function is up here, if it is supported, we are passing in a video tag or a video element as our HTML tag. If WebCodecs is not supported, we are passing in a canvas element as our HTML tag. The last thing I want to do is set my state accordingly. We're going to set this to true because we have started sharing our screen, and this is only going to be triggered if there is a change to our share screen state or our media stream. All right, so I'm going to go ahead and save this, and now we're going to do a quick review of our return statement. Again, this is mainly UI. So the first thing we're going to see is we are using a ternary operator to check and see if we have SharedArrayBuffer enabled. The same way that we determined how we rendered our video above is going to be what we do below. If we have SharedArrayBuffer enabled, we're using a canvas tag. If we do not have it enabled, we're using a video tag. We're doing the same thing with our WebCodecs. If WebCodecs is not supported, we are using a canvas tag. If WebCodecs is supported, we'll be using a video tag. So again, we have two separate ternary operators to check and see about each of those things for how we're going to render our video and our shared screen appropriately. The next thing we're going to see is that we have some more ternary operators so that we can render the text for our buttons appropriately. So for instance, if my video is started, I want my button to read stop camera. Otherwise, I want it to read start camera. Same thing for our share screen button and same thing for our audio button below. All right, so now we're going to go ahead and actually look at a working application and see what this looks like. So I have a version of my application up and running, and I'm going to go ahead and show you what it looks like to start my audio, my video, and to share my screen. So I'll click here, and we're going to notice that when I click to start my camera, I have my permissions popping up inside of my Chrome window. So I'll click allow, and my camera is on. Now I'm going to go ahead and start my audio. Same thing, I'll click allow, and my audio is on. I can mute and unmute myself. Now I'm going to go ahead and share my screen. And that's working properly. I'll go ahead and stop that. And this is what the working application looks like. All right, that's it for our build with me today. Thank you all so much for joining me as I built a simple application using our video SDK. Make sure to click on those links below if you want to learn more about the video SDK, and feel free to reach out to us on the developer forum if you ever run into any questions while building. That's all for today. I'll see you all later, and happy coding.